Hello, this is my name is George. With my colleague Holger, we will guide you through the session. The session is about optical sensors and the snow test center. Well, here you have also our contact details so that you know. Well, I mean, Holger is the product manager of the optical sensors. Myself I'm in sales, but I also do support. Yes, we have a question button, and so therefore at the moment we will stop here. We have a chat button in case you have any questions. Use it. Yes, I have seen it. So Marijn, thanks for the note. So that's totally fine. If you have a question or an issue, just use the chat. We will see it here and we will answer as soon as possible. It might be that there's some delay due that I'm now speaking and not answering directly, but if you have a question, please raise it. The best would be actually if you raise it just through the chat, and then we will pick it up and bring it on the screen. Yeah, again, so if nothing is there, we can start. Oh, okay. Yeah, that's right. I can just a moment. I just noticed that there's a function of the moderator to switch off all microphones. So now you're switched off, but you can still use the chat button. So please don't mind. Just use the chat button, and you can communicate with us. But so now I hope the noise level has reduced. So let's go ahead. Our agenda is we will give a technical overview about the sensors of the different versions of the snow sensor. Then we have the largest part, and that's installation, configuration, and startup. So how the mechanical installation will work and the electrical configuration. We have a service part about maintenance and so on, and we have also picked up a couple of frequently asked questions. And also in this section number 4, we will also have the option to answer to the questions throughout the meeting. However, if we see that while we are talking there's an important question, we will also stop and try to answer it. In the end, we have a test. So this test, it will lead you to a link. Just briefly, we have a couple of distributors and local dealers participating. So we have kind of a certification program. So it's mainly directed to these partners that they participate in the test, they check their knowledge, and we can certify them. But if you want to take part, please feel free. It's a nice challenge at the end, and well, you will see the link then. So the technical overview, very briefly, it's the snow sensor is it's a laser sensor. It determines the snow depths up to 10 meters. Which is important is then we have a second measurement, so every 6 to 10 seconds a measurement, a result is given, and it's millimeter precise. Which is also important to know about the snow sensor is that it has a visible eye-safe laser light, so you can see the light. You will later see it also. It's a red point. It is eye-safe, however, it is not advised to directly look at it for a long time, so in the laser. Which is important. What important is about the laser distance measuring method is that it's temperature independent, so it is very stable throughout different temperatures. And here you see a nice picture from our customers in Austria, which is actually in Konyaan, yes, at nearly 2,000 meters altitude. We have different applications. Well, the most common or popular application is in the weather service for forecasting and monitoring snowfall. We have a number of applications for traffic and aviation safety. So at airports, we see it along a number of highways. Winter sport areas, we have a number of increasing applications in winter sport areas. For example, in Austria, a number of hotels like to have it to give their customers the perfect or the exact snow condition. So we have that, and of course also along the different slopes you see them. What is also an important area of application are water and energy sectors. So, for example, for hydrology and hydrological power plants, they're interested to know how how the snow is melting, and so to monitor also the snow melt. However, and that's a side note, you can't measure the water level with it. It's really a snow measurement device. So just we will have this later on also again, but it's really for monitoring snow levels. We have a number of sensors. If you have questions, or if I should repeat something, I just please, if I'm too quick, please let me know. It's I might get carried away. We continue. Type of sensors. We have three main type of sensors. You can also see that there's number 4 here, which is not really. It's there, but it's a special firmware setting, so it's not really popular. In fact, so we have 3 sensors. The difference is the interface, and then you have number 2, the sensor, which is RS232H, meaning that it has a heating function. It doesn't mean that the others don't have a heating, but it is possible just to manually alter the heating settings. So that it's a main difference. We have different cable lengths and also mounting clamps. So the standard cable length is 10 meters, but it's also possible to get 5 meters or even longer. However, longer than 20 meters, we do not really advise. And regarding the mounting clamps, the most popular mounting clamp is this one, the 80 millimeters, no, the 72 millimeters or 80 millimeters. The difference between these is a steel band, and the other one is really a clamp. So the steel band you can see here, and the clamp is that you have 2 devices. You just put them around the mast, and then you have to screw them. And with the steel band, that it's the length of the steel band decides basically the diameter of the mast you can apply to it. It is also possible to get an extra power supply, and of course each sensor comes with a documentation which includes a USB and a manual as well as an installation guide. Yes, labels, which is it's still important to note that we have this label on every device, meaning that it's really giving you a warning label that it's laser class 2. You do not, as said, do not stare directly into the beam. It is especially important if you have it in public areas installed that you have this label, and some customers and users, of course, want to know this. We also have here the identification of the sensor. So this you can see here, that's the RS232 version, and here then 836.11 for the heating function, or in this case, this is actually should be 20. Then it's RS232 version. You can see the different serial numbers. This one is actually important for the installation, and it's in the inner housing, so you can here see the connection wires. So these are all the wires you will see, and the different notifications. Here is the laser exit, and again, which you really look into the laser, you can see that this you shouldn't do because it might harm your eyes. As said, this is a basic overview of the scope of delivery again. We have the communication cable. You can see very nicely here that there are different colors and of wires, and so you can actually just have one cable and all the different connections can be made from there. You have this one is actually then going to the sensor. Well, you see that there's a USB stick and pretty self-explaining, I must say. About the measuring principle. So as I said, we use a laser, so it's basically a modulated high-frequency light. Actually, how is it measured? How do we get the result? Is that we compare basically it's a time comparison, how long the signal travels. So it's important when you start that you have an offset, and then the sensor is comparing always to this offset. The microprocessor is calculating basically the phase shift and the distance. So you have to note that the laser is traveling, or different wafers are sent out, and then these wafers are analyzed and compared. Actually, 5 different wavelengths are or frequencies are used. And which is also important then to know is that the reflection, well, it's basically the time which is coming back, which is measuring then the result. The setup inside, you can see that there are 2 lenses, one the diode to send out, and here is it received. A quick overview about the settings. We have it's a lot of information. I should again stress that we have here the 10 meters. That's very important, and then we have. I can see it now. Yeah, we have the power supply is actually, that you should note. We have without heating, it needs 10 to 30 volt degree and 15 to 24 with heating. So that's it's always interesting about power consumption if you have it in off-grid use or not. Here the safety parameters are installed. Operating parameters, temperature ranges between minus 40 degrees and 50 degrees. The heating activity actually can be programmed below 0. What is interesting also is that you have, yes, I didn't mention it yet, so you have this signal interface, RS422, you have RS232, and you have also an analog signal mode. So we will also talk about how to connect it in the analog. Wait. Actually, you can see it here when you see it, that yes, here the analog figures. Well, it's just an overview. It's also included.
Yeah. So just a second, I wanna add some remark for the SNODEV. We had old data sheets, and in the old data sheet it was stated that the measuring distance is 0.1 to 15 meters. These days now we have just 10 meters in our data sheet. Why? The reason is that in the past, before 2012, we measured only, more or less, only the SNODEV, and the sensor were only calibrated for SNODEV. And for SNODEV, in principle, the total measuring range is the same as for hard to 30 meters. Due to our stray light reduction, we have a limited distance to 10 to 15 meters. Why we have just 10 meters now? We have it because in 2011, 2012, we introduced the signal strength measurement technique, with a calibrated on a calibrated signal. And this calibration process, this was done just for the signal strength for up to 10 meters. So also today, this in principle, the sensor can measure up to 15 meters for snow, but for this signal strength value, which you have in a digital channel, this is limited to 10 meters only. That's the reason why we have one value to make it not too much confused for any user. So we have one value these days with 10 meters, and the 10 meter is valid for both, for the signal strength and also for the snow depth itself. That's the reason.
Okay. Yeah, thanks. Important. Yeah, so that was basically the first area, and then I think, Holger, you continue with number 2, installation, configuration, setup.
So I will also switch the webcam from us to another one, which we used for a setup. Yeah. And just a second, I want to make sure that it's that you can see it very good. Okay. So for our upcoming presentation. But first of all, for the setup. The sensor can be mechanical installed on a mast, or you can also use any horizontal bar to install it or whatever. Keep in mind that you see sometimes, due to the sensitivity of this laser sensor against the ultrasonic sensor, you see sometimes the movement of the mast itself because of the very precise measurement with a millimeter precision. You can directly see, for example, the heating cycle of the mast itself during a day. If you have installed the sensor at 7.5 meters height or something like this, the mast is definitely moving during the day. Especially if you use a horizontal bar on it, then it's more. So you see here, I think, a clear picture how we suggest that you should install the sensor away from the sunlight. The angle, installation angle, shouldn't be too high, because then there is between the surface and the laser beam, you see you have maybe any rough surface, you see just a small little 5 centimeters hill you can already see, and because you hit it before you have your real measurement. So it's an angle like this, a very steep angle, is also not very clever, due to the fact that typically you have some thermal heating from the mast itself, and with the sunlight. So this is definitely a possible installation, and sometimes it's not. You don't have the choice to tilt it in the north direction in the northern hemisphere. So you definitely have to think about an installation like this. But we saw in the past, when we developed the sensor 5-6 years ago, we made some tests in high mountain areas above 3-4 kilometers height in Austria, together with the people from the Austrian Meteorological Institute, and they find out that we have some limits when the global radiation is getting too high, and then it's reflected from a very from a snow surface, very dry snow with ice crystals. Then you might have so much background light from the surface that the measurement of the sensor itself starting to produce error when you have a direct reflection angle. This could happen. This is the reason why we suggest the fourth picture as a standard installation. And in between these first tests we did in Austria and today we improved even these possible background radiation level, yeah, due to a small diaphragm and other things which we integrated in the beam path. So the mounting clamp is clear, I think. I don't have to tell so much about it. It's again the standard mounting clamp. You see here 360 degrees pattern. You see a 360 degrees pattern there, and so with a 10-degree resolution. So this is I think you can reach the most important installation angles like 10, 20, 30 degrees very easily, and then you can use a fine-tuning if it's required. Again, here you see also the full installation process, so you have to dismount the cover to connect the cable, and here is a certain way how you can fix all these on a mast. If you first of all install the mounting clamp on the mast, then you need no further tools. There are no tools required to fix the rest of the sensor on the mounting clamp. So for the mechanical installation, we suggest two ways now to find out the inclination angle of the sensor. So typically, so here you can see first of all with the horizontal bar, when the sensor is mounted on a horizontal bar, these are the pictures from the manual. Yeah, and here is an additional picture of it, and you see you have now three possibilities. Of course, one is you have already this 360-degree pattern, the pattern disk, and if you don't care about too much precision, you can just read out how many look vertically to ground and count the number of holes, and you can just rotate the sensor and find out, okay, now I changed it 3 holes means 30 degrees, and if you do this installation with 30 degrees and start with the measurement and then you enter this value in the interface, we come to this point later, yeah, how to do it. If you enter this value, then you find out very easily that it is already precise. So it's not an absolute very big error which you made. There are two other methods. There's a method, triangulation method, and one method is using, let's say, the sensor itself without any additional help. So what are you doing here? So I present it a little bit maybe on the camera. What you're doing here, you tilt, first of all, you rotate the sensor, looking to ground, like this, point to ground, do a measurement, then you do the same under the angle which you wish. You can release it, fix it again. Okay. So then you fix it again and do another measurement. And okay. And with this different measurement here now, you have a kind of one measurement which is the L, one with the H. Yeah, but of course you do this rotation, and here you don't do You have both. You have a rotation angle. Let's call it off. You have a rotation angle, and you have the two also a transition, because when you rotate, you don't rotate it directly where the laser beam starts. You rotate it here. You have a kind of offset, and you need a kind of correction for it. And this correction term means, in case of the sensor, for 30 degrees, it depends on the angle. For 6 centimeters, for 30 degrees, for example, you need a correction term of 6 centimeters if you want to do this kind of installation procedure. So we will offer, so we found out that it's not too well written in the manual, so we will improve it a bit, and we will give these values for the standard installation angle in the next manual setup. There's a third method, and for the third method, you use, for example, you use the help of a tool, for example, your cover. So in a moment, we are doing measurements with this sensor where we remove the cover. Yeah, you see we have connected it here, yeah, and we're doing this measurement with the method, with the third method of principle, and we're doing a measurement here to the cover or to the floor. Yeah, and with the help, because this kind of cover you have always with you when you install such a sensor, has roughly 30 centimeters, you can do a very precise measurement of the height of this cover plate before you start with the installation. So in real, it's 30.2 centimeters, something like this. Yeah, and then you can use the method number 3 to do such a measurement. If you do it, you have again, here is just about the inaccuracies which you are doing, inaccuracies. So the counting hole method, means roughly 1 centimeter absolute error if you do an installation at 2 meter high. So it's already quite precise, and the question is if you need something better or not. Yeah. There's other method, the triangulation method. This is a little bit undefined. Reason is you have also some mechanical. So if you do this installation here, you see that you have there is some play. If you release it and mount it again, you must be careful to do it in the original position, because you compare two results, and so the total error might be in the same let's say range as the counting hole method. In case you have a flat surface where you can put, for example, the cover on it, it is the best maybe to use a third method. With the standard, because you don't need this correction factor anymore, and you can reach a millimeter precision if you have can do this kind of measurement, yeah, quite precise. So that should be fine. So I will have a look if there is any if you have any questions so far. Okay. So not yet. Okay. So when we come to the next step is not the mechanical, it's now the electrical connection. In principle, you have 3 methods. One method is the terminal program, R232. One method would be the analog with the data logger, as you can see it here. Yeah, and one method, the last one would be any other data logger which you can use. Yeah, for example, in this case here you see a couple CR1000, where you can also connect the RS-232 signal. Yeah, so in our setup, for example, we have this directly connected. This is connected in the moment because we use it actively for this presentation here. It is connected actively with the Enercon from Lufft, and also directly over the RS-232 for the configuration. Okay, if you connect the cable, yeah, you have here, I don't know, if you connect the cable, then you have here the blue and the red wire. We have a scheme too, which comes a few slides later, and then you can easily see how it is always connected. So we prepared a new setup, which is will be integrated in this kind of a folder, which George announced in the beginning. Yeah, and then you can correctly connect this to the Enercon. Okay, for the different wires, you see there is the here you see, for example, the option for RS-422. For RS-422, we use the brown and white wire, and these brown and white wire, these have different meanings. Yeah, and sometimes it's used. So the rest is fixed, but the brown and white, it's sometimes used for the RS-422, could be used for, here you see an RS-232 option. Sometimes it's used for this heater off option and so on. If you connect it for the RS-232 or the 422, you need a kind of terminal program, and terminal program should use these COM port settings. So it's a little bit different from the UMB COM port settings, which are always runs at 19200. So the standard communication baud rate for the sensor itself, it's 9.6. Here you see, for example, a terminal program in a slide, but the same I can also show you a little bit later online. And there are different commands available in the full parameter setting, which you can find in the manual too. Yeah, and there is a telegram output over RS-232, and the telegram consists typically of the snow depth, of a signal strength value, of something like a temperature, of an error code value. Also the list of error codes is available in the manual too, and finally a kind of calculated check byte at the end. So for the RS-422, as I told you, the connection is a little bit different. You use the brown and white wire here too. Yeah, and there's an option which we are using here now, which I mentioned. We connected the RS-232 directly to the PC, and we connected the Enercon here additionally to work with the UMB configuration tool or the SmartView software from Lufft. For the this comes a bit later. Just a second. I will switch to a terminal program now, just to show you some of the commands. Because I used, for example, here one command. I permanently switch on the laser. I used it, yeah, because when it's flickering or whatever, then it's very difficult maybe for you to see it. So there's a laser on, a laser off command, 2 for the installation purpose, which I used here in this kind of terminal program, which you hopefully can see. Now, for example, I have the option with our setup. I can go through the different commands which you see at the bottom row there, which is available for a terminal program. Here we use these, for instance, these brace terminal programs. The reason is that with a brace terminal we can put in some of these macros very easily and have, for example, escape command or command to ask the sensor itself for its ID. We can directly press a button and don't have to enter all commands which might be used during the setup process. So, for example, if I press the ID command for the sensor, I get an output. In the header, it's written that it's an SHM 30 sensor, which firmware is installed, and that has a certain serial number. And then there comes a list of all major commands. Let's say these are not all available, but all major commands. And here you can see also, for example, in this list, you can see this laser on, laser off commands, which I used to switch off the laser. Okay, there is another command, a bit similar, it's PA, and PA asks the sensor for all parameters. So I will clear it before I press it again. Again, PA asks for all parameters, and for example, here you find that the baud rate is 9.6 and commands about the heater and so on. We already put a distance so that when I start with the measuring correction distance, when I start with the measuring, it will directly, yeah, used. Good. So let's once start from the beginning how to set up such a sensor. So in principle, you should first of all you measured the inclination angle. And now you have to enter the inclination angle in the center. So what should be done? You have a command, it's called SP, it's a command for the inclination angle. I can ask which angle is installed. In the beginning, you might, the standard delivery, of course, is 0 degrees. So I can set this inclination angle by putting SP and a 0. Yeah, and with SPO or SP0, you can see now the sensor inclination angle is set to 0 degrees. When I know the sensor, so here I know I have tilted 2 holes, I can set up the sensor to SP20 if this is precise enough. It is precise enough for me right now. Yeah, the other took a little bit more time, which I won't spend here. The other methods. So SP20. So now I have the correct inclination angle. Then I will, for example, can show you one telegram. I can start a measurement by pressing XM. Yeah, it's starting now a snow depth measurement process. The measurement is done, and then there's a certain output. And this output you see here, the standard output, is in meters. Yeah, I can stop the measuring process by pressing escape or by entering a terminal program, a terminal command like escape. I can just also press, when I have a terminal program open, I just can press a keyboard. And here now I have the E67, which is a standard answer that the measurement was interrupted. The standard error answer for an interrupted measurement. Okay, here I can see now this E67 measurement, and I can look if this meter is correct. I have the possibility of a so-called scale factor. The scale factor in our case is 1, and 1 means I have really a meter precision, but I can switch, for example, to centimeters. And centimeter output I can change by SF100. Yeah, SF100. And with SF100, for example, now I change when I restart the measurement. When I restart the measurement, you see that this value is changed from 0.3 meters to 30 centimeters. Again, I stop with escape. I got it. And I can, for example, enter a command which is not understood by the sensor. Yeah. For example, just press once escape. Yeah, E67. And when I press any command, like now just the return, the carriage return, which the sensor cannot understand, the sensor is answering with the E61 error. So always when you write something which is where a command comes out which the sensor cannot interpret correctly, then the answer is the E61 error. So these two E67 during the setup, just indicating that the measurement was interrupted, and the E61 might be the 2 errors which happens during this installation setup. Yeah. So E67 is more a wish. You want an interruption of the measurement. E61 is an indicator that you make something the sensor couldn't understand. So again, I changed the scale factor. I will switch it back right now to 1 to work with the meter scale. Of course, you can also use a factor to change to a feet scale if it's required or something like this. So you can enter any scale factor to change the scale to what you want. So now we have again SF1, and one next step, for example, is now I'm pretty sure that I have already the correct angle installed, and the next step would be that I start, for example, with the measurement. And standard configuration is also that the offset is 0. And with the offset 0, okay, you see here, now when I start the measuring process, I get a certain value. Just wait until we have done one measurement, and I stop here again. Well, that's understood me. Okay, now it's interrupted. So the first measurement, I did a kind of a starting measurement, and now I have measured the distance from the sensor to ground, which is in our case here now where 1 meter is 66, corrected with this 20 degrees inclination angle. And of course, this is a minus distance. Why? Because now I do a 0 measurement. So I determine the distance to the ground with the offset measurement. And this offset is always, this value which is measured here is always subtracted from the offset, because finally we want to have some snow depths. And with the snow depth, it's a positive value, so we want to see something that is growing from the ground. So we level the ground to 0 by doing an offset measurement. And an offset measurement can be done by the command SO. If we start it, it's done here, and the output it's O is 1663. So roughly the same what we measured before. And now I restart the measurement. And when I restart the measurement, I have now the the real snow depth result there, because now I can run this measurement and it's the ground level is zeroed. Okay, so that's one of the steps, the typical steps you have to do. You install the sensor mechanically, you measure the angle, you give with the command SP this angle inside the sensor, then you decide what kind of scale factor you want to use later on, then you do an offset measurement, and with this offset measurement, after this, in principle, you are ready. Okay? So, when you are now in the field, you want to check if the measurement quality is good or not so good or whatever. For this purpose, we are using this kind of plates. These are photo plates. There's a plastic back and a black cover, and we are using the same tool with a white cover. And you can, for example, put these on the floor where you expect your laser beam, and after you have a result, and please have a look at the second value here. I have now, within the uncertainties of these plates, I have a value of 0.8 in our case here for this kind of black value, and I do the same with the measurement for the white value. And I see I have here now 8.4. So what does it mean? Typically we have altogether we have roughly 1 for the black photo plate and roughly 10 for the white photo plate. And this sensor here, which we installed here, was coming back from a customer due to calibration issues. So we see here there is a slight offset, and this offset is in what I would say it's not as big, so it's within the tolerance. So we have a factor of a 20% tolerance for these kind of values. So it's within the tolerances, but so roughly this kind of method which I've shown you with this 2 photo plates, this is the standard procedure which you can always do very easily in field, check the values which comes out, and this helps of course a lot to give a first estimation if it's alright, if the sensor is correct or not. It gives you an idea. When it's within 10%, it's quite good. If it's within 20%, it's still acceptable. Good. So I will check if there are any questions about this. No, there aren't. Okay. So then I will show you again this setup. Show what I'm doing here again. we go in the presentation, in the presentation now to the next setup. And the next one is if you use the OMB tool, this one. If you use the OMB configuration tool, just for example, if you want to connect this sensor on an analog way to the analog. I showed you already, so we connected it here, and in a moment you see it is already configured, and we're doing here measurements in the analog channel. So I have now a problem. I know when I look at the sensor, I can stop with this measurement here in this analog, and if I'm doing the configuration here of the sensor, I must finally set this range, this 4 to 20 milliamp range, which comes out of the sensor. I must set these two values to our UMB configuration range, and I must say, okay, 4 milliamps corresponds to a special height, for example, of 0 meters, and 20 milliamps of a maximum snow depth height, which you expect during a measurement time. So you have in the configuration of the laser snow depth sensor, you have these two values for the analog range. The values are RE and RB. So RB is the beginning of the analog channel. I can stop again my measurement and ask the sensor now where it is. It says RB is set to 0 meters. So when you have receive a new sensor, RB is set to -5 meters. So the standard delivery is -5 meters to +5 meters. Why? Because if you connect the analog, look at the analog, and you have not done no offset and measurement and everything, and no angle correction. Then you start, for example, like in the beginning with -0.6, with -1.6 meters, for example. You want to see something on your analog. If you set RB in the beginning already with RB0, then you might, or we can do it by default from in the manufacturing process, of course, too. But if we would set this in the beginning, then this means you are always out of range, also in the beginning. So please, you should change these values to those values which you expect. In case you have leveled to 0, like I did, the sensor, in a good setting is RB -0.1, for example, in our case. Again, remember that first of all you must decide the scale. So the scale is important. If you have the scale factor not set properly, for example, to centimeters, you finally want to work with centimeters. Then RB is still set to meters, and later on you change SF to SF100, you have different scales. So select the scale factor, and then you have a measurement, and then you say, okay, a good setting for the start process is minus, in our case here now, 10 centimeters, 0.1 meter. Because it means if the ground level, sometimes you see that these values, like here in our case, in our example, they are now minus 0.3 millimeters. Yeah, so you have some minus values, and of course you want to be sure that your analog signal is always in the correct range and you see anything. You see also the minus signals which can occur through moving of the ground due to frost, freezing processes in the ground, but it could also to some rest uncertainties of the sensor itself. So the ground level is not zero, it's all could also some minus values. So please choose this. And for the upper range, it depends, of course, on your installation height and the snow level which you expect. You should don't set it to 5 meters if you only expect 10 centimeters of snow. Keep in mind, you have 4 to 20 milliamps, and you want to have a good resolution in the analog scale. So if you only expect a meter of snow, you should set the analog signal, so the 20 milliamp value, to 1 meter. Now, yeah, we can check. In case we have a ground level, we would have 4 milliamps. In case we have 1 meter of snow, we would have 20 milliamps. And in case any of the error occurs, like the E61 or whatever, or also other errors like error 15, if you have too much background light or something like this, or not enough signal, then in this case the sensor gives you 3 milliamps or 21 milliamps, and this is part of the UMB config tool also to do an interpretation as undershoot or overshoot, and to interpret these values as errors. It's a FC80 or FC81 error in case of the UMB config tool. Good, there was a question. Starting from, so the photo plates. There is a question about the photo plates. So the photo plates, as I remember right, the check with the photo plates works, of course, always. What was the difference between the firmware releases? So there was the calibration process changed a bit. From the latest firmwares, there we did a calibration that the values from 1 to 10 corresponds to these photo plates. And so we can use these kind of photo plates and check carefully our values. There is, of course, for all our old firmware versions, you can also use these plates, and you must also have a clear difference between the white and the black thread. It's just that the values are not well calibrated, which you receive. But also in the past, we used this 1 or 0 for black, in case before we used 0 for blacks at the point and 10 for white, so you must always be in this range. The difference could be that you could have 15 for the white or 20 for the white, so much better, and close to 0 for the black. So the calibration process before wasn't done as precise. Or better formulated, it was done only in certain distances. Good. Okay, so for these steps, this is for the analog. I hope it is clear how to do it and why we choose these kind of values, why we choose a slightly negative value, why you should choose upper value in the range of the snow that you expect and not to the maximum detection range, for example. This is somehow important for the setup. Okay, good. I can start here again the measurement. It will go on. Yeah, I have here 4. I can simply try to restart the measurement here. For example, 0.1, and now I can, for example, put, where is it? Over there. So I just, instead of the 0, I measured now the height of our housing cap. You see, it's roughly 30 centimeters. Just with this 20-degree angle, with 20.0 degree, I come to this value already. Yeah. And let's check if this is measuring correctly. And for the anacone value, you see now that for 30 centimeters high, the analog value was changed from 4 to 9. Yeah. So the minimum value, it's still 4, it's listed here, and the actual value, it's now 9, and here it calculates an average. So this is something special from the UMB configuration tool, which can be used there. That it gives you also an average. During the setup, of course, the average doesn't help too much. You should look at this actual value for this channel you are using. Good. This, I think, is the major things for the setting up the sensor. Let's start again with this presentation. I showed you here a test measurement example already. Here you see also an example what happens in case of an error. Yeah, so if I have E60 or E15, whatever error for the digital interface, I see it as a undershoot or overshoot error in the UMB configuration tool. Of course, when I only have connected to the analog channel, I cannot distinguish between two different errors. I always get the same. The next step now, if you using the Anacon and using, for example, the SmartView server, you can go to this SmartView configuration process. In case we have here our meeting room connected to the sensor and have this station information and whatever, and you can activate these analog channels which are already prepared in this SmartView process. But I won't go through the details because it's not used by so many people here in this auditorium. Okay, so are there any questions right now for this installation process? Then we go on with the service issue.
I think there was still the black and white question that someone said.
Level of water is snow, ice, snow, just a second. There are a question which I may not answer.
So yeah, there was, just go down. Difference between white and black foil. Just
okay. So I missed one question. So we are using these photocopy papers. It's from Photowand. It's you can order it in the internet. These are, let's say, plates which also is quite resistant against UV scattering, so it will survive in the field for a while. It could also be wet. We have also a gray one. Yeah, we use it for our calibration issues to have a 50% plate with 50% reflectivity. The white one is roughly 85% reflectivity. The black one, which we are using, is 6.2 or 6.25% of reflectivity. So these more or less calibrated plates are used in the classical in the classical photo camera technique, if you want to have a gray color just to improve your white point, for example, of your settings. For this they are used, so they are somehow well calibrated in case of reflectivity. So we say that this 85% reflectivity is close to snow. Of course, this is not always right. Snow could have 90 or 100% reflectivity, could also have 60% of reflectivity. Yeah, and the same is, of course, for the black. We use this as a kind of lower point, but it's still 6% of reflectivity. And in the natural, you find more absorbing materials than this black, this 6.2 rest reflectivity. So you could have lower values as 1. For example, if you measure on a roof, which is also one of the applications for our sensors, this kind of snow removal from any roofs, and you measure there on this very black absorbing surfaces on a roof, you could have values of 1.2 or whatever, so just below this 1 value. So we use this white and black as the 2 calibration points, one at 10, one at 1, to have that everybody can check it in the field if the sensor is still measuring somehow in this range. And we say you can use for discriminating of snow from grass or from other surfaces, you can use a kind of threshold principle. You can set your threshold value to 4 to 5 or whatever, and you can roughly be sure that above 6 you typically have snow, and if you have just values of 1 or a maximum 2, there's no snow. So it's this kind of no snow discrimination idea which is behind, and these white and black panels, which is used for service 2, which comes now in section 3. These are helpful parts for it. Okay. So options. Options. Good. For part 3. Good. For part 3, we discussed a bit also for these error codes already, yeah, and we said these values are available, yeah, for RS232, RS422, yeah, and of course there are error codes, there are different error codes listed in the manual too. There are these specially called communication errors, which we said E65 is mostly eliminated because it was a firmware thing that when the sensor was measuring and you tried to poll or ask for a measurement, then this kind of the answer was sometimes a measurement interrupted, and this kind of error there was this E65 error for this purpose. So we eliminated it starting, I think, from firmware 908 or 907, and since then this error is not as often anymore. The E17, E15 are the most errors due to daylight. Yeah, so in one case, the reflectivity of the target is getting too poor. In the other case, the background light is too high. Here you have this full list of errors. Yeah, E17 background light, E16 signal too strong. Yeah. So there is still one question. George told me. I think we come to this point when we speak about different applications a bit at the end. Yeah. So also the temperature. Means the temperature for the laser diode inside of the unit is too low or too high. Typically, there's an extra heater to extend the temperature range to -40 degrees. But here you see already what when we speak about this heating process again. So in principle, until -10 degrees, you can measure without any heater. So it also reduces the power consumption of the sensor completely. Yeah. But of course, you must be sure that the optic is and everything is still free of snow or ice. Yeah. And the 61 and the 67, I tested it directly, is the interruption by the escape command in principle. Good. I have not mentioned one, and this is a E66. I have not set these values in my presentation yet. So this is a kind of value which can be set by the variable XP. It is used if you want to say that between two different measurements, the snow depth value can, for example, only change by 2 centimeters, as an example. Then you can set XP to 0.02, and in this case, when you have 0.02 for the setting, okay, you can be sure that this value is not, that if we have an overshoot due to a bird or a kind of animal or whatever, and you measure something different, then you receive an error instead of this confusing error because it has not snowed 10 centimeters or 20 centimeters within this minute. So there's a faulty measurement, and this is a filter technique for removing faulty measurements. Here you see this is also available in the manual. You see what does it mean in E15. You have in 3 or 21 milliamps, and you can handle these two values as errors also for the analog channel. In case of a telegram, you receive here these E errors as I mentioned before. Good. Will you go on or should I go on? Yes.
You want? Yeah.
Okay. So for the cleaning and other processes, so what can be cleaned and how to clean the sensor? So in principle, you have this housing, and for this housing, you can of course always remove the cap or whatever, which is quite easy to remove it. And then you can clean it a bit. It is also without removing any parts to have some air pressure to remove some small dust particles or whatever, and insects if it's possible in the optical tube. So of course there's always a case when you have to dismount the sensor itself. Not the complete sensor. In this case, we would suggest to remove just, I will switch the webcam once more, to remove just the black part here. Yeah. In this case, when you remove just the black part, you have to unscrew it. You will see it in a slide after it. You can remove it, and then you can easier clean the optics. This can also be part, and as a procedure, you don't have to dismount the whole sensor. Yeah, you can do it in the field too. Yeah, until a certain level. For example, when you can do it, when you test with your white sheet and black sheet, and you see that it is a loss of energy. You see only, instead of 10 with the white photo paper, you see only 5 or 4. This is a case when you have to check the optics if they are still clean or not. So you should, in this case, do a careful look, switch off the laser, maybe to be able to look inside the sensor with an LED or with a flash lamp or whatever to check if it is all right, and if there are some spider nest or whatever before the laser optics, you must remove and clean it. Here you see this procedure, how to do, and maybe also the tools which should be with you in the field if you have to do some service on it. Yeah. There is a different service step which I will show you here, but it's absolutely not the standard service. So it's also not the standard service for Lufft itself, because the blue sensor is manufactured in Jena, so by Jenoptik. It's part of their industrial production, and the repair and changing of parts which are inside the blue housing are for Jenoptik service people only. So we shouldn't use it, and you shouldn't do it. Yeah, it is a loss of warranty in this case if we open the blue housing. The same is in a moment also for firmware updates. So Wolfgang König from Jenoptik, my old colleague, so to say, is still responsible for this kind of service work, and doing, for example, firmware updates. A list of firmware updates you can also find in the manual. And the latest one, you can download the manual from our webpage in case you have an old version and want an actual one. Good.
Yeah, there are 5 minutes left. So
okay, for the frequently asked questions. There's one question for level of mixed water snow and ice snow level and whatever. So measuring anything which is strongly reflecting light or something strongly diffracting light onto the ground, like water. This is something which it sometimes works and sometimes doesn't work so good anymore with the laser. So it's not a clear answer. It depends a little bit on the condition. On a clear water surface, it's definitely not possible to measure with this laser, like water level measurements. We wouldn't recommend this kind of laser technology for it. Reason is this kind of comparison method which we use with this laser. So we don't measure directly the speed of the light and the laser traveling time. So we are doing this phase comparison method. The phase comparison method takes more time than a pure speed of light, and so measuring small waves or whatever, which sometimes want to be achieved by water level measurements, cannot be done really, because the measurement principle in this case of sensor is too slow, simply too slow. And a different issue is that the light from a kind of surface which acts as a mirror, this light is definitely reflected or from the surface, or it is diffracted to ground, but under a different angle. So it's not coming back in the same and on the same way, and we cannot really measure it. So on anything which has a kind of mirroring effect, or which where you can clearly look through, you make different errors during your measurement. Sometimes then it works, sometimes not, and you don't understand exactly why. So I cannot really recommend it for this measurement. Ice surface is relative. It's also a rough ice surface, and sometimes, it's a very transparent surface.
There are more questions. From Nepal, yes.
Yeah, so
what problem can we expect?
So the problem is if you, for example, don't have the power, you cannot run all SHM sensors. You cannot have the power for the laser, for the heater inside the laser diode. What happens? It happens that below -10 degrees, -10 degrees inside the sensor, so it means -12 to -15 degrees, depending on wind shear, the laser is simply switched off. It protects itself by switching off. If it's getting warmer again, the laser is switched on again. So not more and not less is happening. So in case you have not the power for any heater, you can use these heater parameters HO, HF, where you can set when the heater is switched on, when the heater is switched off. You can set the values to -30 degrees for switching off the heater. It means in principle that the heater never starts. And if you select values like this, of course the power consumption is low, but when it's getting below let's say 12 degrees Celsius, then the heater is switched off. The laser is switched off, sorry. This happens. So about aging effects of the sensor. In principle, if it's a regular sensor, so without any problems, so I realized that also in Jena, one charge was produced a year and a half ago, which had some minor problems, and these lasers were exchanged without extra charge. But in principle, the laser diodes have a lifetime of 40 to 50,000 operating hours, depending on where, of course, how they are operated, so how stressful it was all the time. So it cannot be clearly answered. It means if the people use it 24/7, year-round, then you have 5 years roughly where you shouldn't expect any problem with the sensors. When it happens, the laser module inside, after this, the laser module, which you saw in one of the slides before, must be exchanged. And also a new calibration should be done anyway after 5 years. So typically, I think you can run these sensors at the end. If you want to check time by time if the calibration is still all right, you can use it, can do it with maybe 3 or 4 distances in your office too. You don't have to send the sensor really to us. You can use these photo plates, do this routinely check, clean the sensor carefully before you do this check, and find out if it's still all right. And if it's still all right, you don't have to do anything. But for long-term use, you should expect 5 years.
That's the last question.
Unsuccessful.
SHM 50. We can also go ahead because I still had another very nice question, not the solar one. Yes, because I mean I will send you the presentation afterwards. Sorry, Holger, to
interrupt. It's fine. You must go.
We just have a couple of minutes left. One very popular question is actually how can I avoid that the sensor gets covered with snow? I mean, wind protection and so on. So actually, we have this nice example from Austria. They have set up an own tube in order to protect better the optics against snow cover and also against wind. The diameters are mainly that at the front it's 70 millimeters, in the middle it's around 100 millimeters, and at the end where it connects to the optics it's 50 millimeters. At the moment we are not offering such accessory. We are considering to do it. It's still in the planning, I think, but you might want to try it on our own. We are actually hoping to get a technical drawing from Austria once, but as soon as I have it, I can share it with you if you need it. But just that you know that it's one of our most popular questions, and that's a good solution. Still,
just one add-on. So
yeah.
Just yesterday we had a meeting with the construction for this issue, because there are in principle two side effects which can occur. So we had some which says in summertime they might have at some of 100 locations they might have some insect problems where they have to clean the optics. Once in autumn, for example, before the snow season starts, they have to remove some spiders, but also some others too. So we are testing now an additional glass plate, which should help to make the cleaning process easier, and which helps also a bit that the spiders, at least at those locations, cannot enter it as easily as in a moment. So there are two accessories planned by Lufft to avoid snow effects, freezing effects, and especially in wet, cold areas, and also some summer insect effects. Okay.
Yeah. Good. I think our time is nearly up. I would. Well, I will send you the questions. I think that's the most pragmatic way now to go ahead. In case you still have any questions, please drop us an email. We also would like to give you, wait, no, this is not, now the link to the test, which is actually 10 questions, approximately 30 minutes. You don't have to take it right away. It's online for a while, so of course, it would be good to do it as soon as possible, so now you still have everything in your mind. Yeah. Can you, maybe I will just enter it in the chat so you can have it already. And here you are. And then, as said, we will send you a copy of the presentation. We will send you a recording or a link to the recording. And then, oh, this was only, sorry, I sent it just to one, so I sent the link again to everyone. Yes, and actually I will now switch, well, now I officially close the meeting, but we are still online. I switched on the microphone, so if you want to bring anything forward, we are still here. Just now that the official part is over, and we are still a couple of minutes online. And okay, so now you're online. Thanks a lot for your time. I think we tried to make it on time, and yeah, hope to see you in Brussels. We will be in Brussels for sure, or
Okay.
in other occasions. Yeah.
Okay, cheers guys. Greetings from Finland.
Bye-bye.
Bye-bye.
Bye, thank you.
Marine, ja. Das könnten wir machen über die.